Hello guys, this is Prime Concept. In this video, we want to solve a problem that pertains lens maker's formula that we derived in our previous video. So we'll be analyzing this concept in such a way that the concept of lens maker's relationship will be very clear to you. So do well to stick with me in this video till the end and you will get serious value from this video. Thanks. Now let's look at the problem we have on the board. The question says two equiconvex lenses. So take note of the word equiconvex. So first, we are dealing with a convex lens, and then they are telling us that there's two surfaces of this lens. Remember, lenses are always made of two surfaces, right? So they are telling us that the two surfaces are convex. And when you say equi, it means that the two convex surfaces are equal. And when you say that the two convex surfaces are equal, it means that they have the same radius of curvature. So very important. So it means that if they are equiconvex, first, their radius of curvature, their radii of curvature will be what? The same. So it means that if I say let R1, which is the first radii of curvature, equals R. Now remember, if we are dealing with a convex lens, we mentioned that R1 would be positive, that is the sign convention, and R2 would be what? Negative, right? Yes. Now, since we are dealing with equiconvex, it means that R1 is going to be positive R, and then R2 is still equal, so but it's going to be negative, same value R, right? So that is one thing we should note for an equiconvex lens. Of focal length. Now, for a convex lens, the focal length should always be what? Positive. So F is going to be positive 10 cm. Is it two equiconvex lenses of focal length 10 cm are placed in contact? Determine their radii of curvature if the refractive index of the lens material is 8/5. So the refractive index is 8/5. So let me quickly change this to decimal so it will be easy for me to use. 8 divided by 5 is 1.6. So our refractive index is 1.6. That is 8 divided by 5. Now, using our lens maker's formula, do you still remember this formula? Of course, I trust that you remember. So the formula is what? 1 by F equals refractive index minus 1 into 1 by R1 minus 1 by R2. So this is the formula. We derived this in one of our videos. So now we know our focal length. So we have 1 by focal length, which is 10, equals 1.6 minus 1 into 1 point. What is our R1? Our R1 is equal to R. And then we have minus 1 by, what is our R2? Our R2 is negative R, negative R. So that I have 1 by 10 equals 1.6 minus 1 is going to give me 0.6 into, this is 1 by R. Minus times minus becomes what? Plus over this, right? So that I have, if I should add up and then cross multiply, I would have that 1 by 10 equals 0.6 into, now since your R is the same, it means you just add up their numerators, 1 plus 1, which is what? 2 divided by R. So that, remember, I'm trying to find R, so I'm going to cross multiply. So I would have R would multiply 1, which is going to be R, equals 10 will multiply 0.6 and would also multiply 2. So that if you solve this, you'd get that R is quickly going to give us 0.6 times 20, which is 0.03. So this is what I'm getting. Let me do it quickly again. 0.2 times, okay, 0.6 times 2 times 10 is giving me 14. 20 times 0.612. So it's giving me 12. I don't know what I punched before. So R is 12 centimeter because that value was actually very small. So R is 12 centimeter. So I believe that this concept is clear. So this is what they want us to get, the radii of curvature, and we've gotten it as 12 centimeter. I believe this is really very clear to you. Please do well to subscribe to my channel so that you can show me your support. Like this video, comment and share with 10 of your friends. 10, tell them this is prime concept. Thanks for watching.